Our SkyFlightCare is going to be a very different type of airplane. Here comes the SkyFlightCare. This is a twin-engine aircraft. Now the SkyFlightCare, unlike the Robinson, uses gas turbine engines. You'll note that it has a fairly similar main rotor system, although in this case it's got 4 blades and it's a fully articulated system. That means the blades are flapping and leading and lagging and hunting and doing their thing round about that rotor head, which only moves in that horizontal plane. Therefore, an aircraft like this can actually endure some negative G's. It's being flown by Nick Kerstock. The other crew are Andy O'Donnell and Lee Mensack. They're all flight personnel with the Brandywine Hospital out of Coatesville. It's an all-composite, medium-weight, twin-engine utility helicopter. Now notice the fact that it doesn't have a tail rotor, but it has a ducted assembly, or a ducted fan assembly, that's shooting high-pressure air out that's doing the same thing to counteract the torque on the fuselage. It has exactly the same tendency as that Robinson to want to naturally rotate nose right, tail left because of the torque of the engines. However, in this case, it's using this ducted fan assembly to push high-pressure air out to the left, thus keeping the tail to the right. Notice the twin vertical stabilizers that help it go forward through the air mass easily. Once a helicopter achieves about 60 knots or so, it can actually fly pretty straight without, or rather I should say straight, without the use of the tail rotor. This aircraft is an air ambulance aircraft. If you hadn't noticed, it executes the same mission as the Penstar aircraft we saw earlier. This aircraft would probably fly to its missions at about 120 knots. That's nautical miles per hour. A nautical mile is about 1.15 or so statute miles. So if we say something's going 100 nautical miles an hour, it's faster than going 100 statute miles an hour. Jim Munda, if you're out there, Jim Munda, if you'd please report to the museum office at this time. Jim Munda. The aircraft is currently heading off to your left. It's actually considered to be produced by McDonnell Douglas. And in the industry, this is commonly called a no-tar, or no-tail rotor design. You'll actually notice that you can see when it comes around that the direction of the fan exhaust on the tail actually rotates. Gas turbine engines, essentially a jet engine, burns something like kerosene. Aviation gas can actually be used as an emergency fuel in engines like this, but they've got to do some work following that. But it can be used as an emergency fuel. Burns something very similar to what you put in your home oil furnace. As I said, it goes about 120 knots. If you didn't hear earlier, we talked about how fast a helicopter can go and what the limitations on that speed are. As a helicopter is going through the air, it's got an advancing blade side, if you picture that rotor disc from on top, and a retreating blade side. On an aircraft like this, you'll notice that the rotor system is going counterclockwise. So as those blades are coming forward on the right side of the aircraft, they're producing more and more lift the faster it goes because more air is coming in to hit those rotor blades. The blades going back the left-hand side of the aircraft are called the retreating blades. Now they're having to work harder and harder and harder, not so much to catch up, but that might be a good analogy, as the air mass flows by it. Eventually, it can no longer compensate with the symmetry of lift between the right side, the better advancing side, and the left side the decreasing side becomes so great that it would actually flip up and flip over. I believe the Naval Test Pilot School does do actual departures from controlled flight with the training blades off, but not something that we want to do at home. This is a twin-engine aircraft. It's always good to have more than one engine if you can. For a naval aircraft in particular, it allows a little more of a chance, you can imagine, to get back to a ship if they were over the water or back to land. It also provides more power, although not always. For example, the old Army Cobras had a very similar payload to a twin-engine Marine Cobra, except that they had one big engine by two smaller engines in the Marine variant. So it's not always just because of more power. It's to give a little bit of a leg up to get you back if we had a single engine failure. You may be able to see the 82nd Airborne team somewhere above you right now. Okay, there they go. November 206 is taking the 82nd Airborne team up. They're going to be climbing to 6,000 feet to do their jump. They're flying at a Bell 206. It's similar to what we used to call a Jet Ranger design. Single gas turbine engine with a conventional single rotor system. And there goes Nick Kerstock in the MD902 one more time. It's also called an Explorer. We mentioned how fast the aircraft is going. Let's say an aircraft was flying past this